How are you, my friends? This is lecture 22 of the Pre-Calculus course about reduction identity. Just to remind you, please, you can review lecture 21 on trigonometric addition and subtraction formulas. And now at the end of this lecture 22, you can find some old exams questions to practice on both lectures. These two lectures are related. So let's see the reduction identity, very important rule, please. Just try to understand that if you have some expression like a sine of x plus b cosine of x, you can write it as k sine x plus phi. Now, what is the idea here? You have addition or subtraction of sines and cosines. Okay, so a is the coefficient of the sine and b is the coefficient of the cosine. So if you have sums of sines and cosines, maybe difference here because b can be positive or negative, a can be positive or negative. But the whole idea is if you have a sum or difference between the sines and the cosines, you can change it, you can reduce it. See, this is reduction identity. You can make it simpler, you can reduce it to k. I will explain the k sine of the same x here. See this argument, it can be 2x, can be 5x, pi x, x plus pi, x plus phi. So let's see the k first. K will be the square root of a squared plus b squared. That's a constant, it's a number. So a is the coefficient of the sine. Even if you have the cosine at the beginning here, it will be still b is the coefficient of the cosine, a is the coefficient of the sine. Now to find the angle phi, what do? Sine phi will be the b, see that b there, the coefficient, positive or negative, divided by the k, which is square root of a squared plus b squared. So you can remember sine of the phi will be b over k and cosine of the phi a over k. Now use both I mean sine of phi, cosine of phi, not one of them. One of them is not enough. Use both of them to find the angle phi. Phi is in standard position. So it can be in quadrant 1 or 2 or 3 or 4. Let's see many examples. You have to write these formulas down or remember it to use it. Let's look here. Write the function f of x minus 2 sine x plus 2 square root of 3 cosine of x as a single sine function. See, we have here sine and cosine together, pluses or minuses. So we need to write it as a single sine function. So we have to use reduction. Now, just to remind you, this is example 6. See, this is continuation of lecture 21. So this is 22. Let's see, let's start here. To write this function as a sine, you have to use a reduction identity. So as I mentioned, a is minus 2, the coefficient of the sine. B, all of this, 2 square root of 3. Let's find k. K will be square root of this one squared plus this one squared. See, this one squared will be minus 2 squared, 4. This one, when you square it, you get 12. 4, 16, square root of 16 is 4, so k is positive. Now let's find phi. Sine of phi will be b over k. B, 2 square root of 3 divided by k is 4, so it will be square root of 3 over 2. See, this one is not enough to tell you what is phi. There are possibilities here. Sine positive, it can be in quadrant 1, it can be in quadrant 2. Now when we find cosine of phi, which is a over k, which is minus half. See, the cosine of phi is minus half. Sine of phi is square root of 3 over 2. Then we know phi is in quadrant 2 for sure. Now the reference here is pi over 3. So the angle phi will be pi in quadrant 2, pi minus the reference. See, we know the reference from these values from the table. Cosine will be half and the sine will be square root of 3 over 2. So phi will be pi minus pi over 3, which is 2 pi over 3. So that's fine. Now I can write this function here, the given, you see, the given function as 4, that's the k, sine x plus 2 pi over 3. Now this function is not easy to graph, you see. When you use reduction identity, the whole function becomes 4 sine x plus 2 pi over 3. Then if you need to graph it, you can go to lecture 15, graphing sine functions. Let's see more nice example on reduction. Given this function minus square root of 3 sine of x plus cosine of x, if the amplitude is capital D, the period is capital P, and the phase shift is capital S, find dp over S. Okay, let's see. See, the minute you see sines and cosines, pluses and minuses, you have to think of a reduction. So write this function minus square root of 3 sine of x, see that given function, plus cosine of x as k sine x plus phi. Let's use reduction. So a will be minus square root of 3, b is 1, the coefficient here of the sine, cosine. So k will be the square root of a squared plus b squared, which is k is 2 now. Let's use the sine and cosine of the phi to find it. So sine of phi will be b over k, so which is half. And then the cosine will be a over k minus square root of 3 over 2. That will be also in quadrant 2, because the cosine is minus and the sine is plus. So it's only quadrant 2. But the reference now is pi over 6, because the sine is half. So phi will be pi minus pi over 6, which is 5 pi over 6, is this phi. Now remember, what do we need? We need to find the amplitude, the period, and the phase shift. Now let's continue here. So k is 2, we found it. Phi is 5 pi over 6. Let's write the function, 2 sine x plus 5 pi over 6. The amplitude, remember the absolute value of the a from lecture 15, and then the a here is the coefficient of the sine, absolute value of 2, which is 2. Now the period is 2 pi over k. The k is 1 here, the coefficient of the x. It can be any number, because we can put here 5x, 5x, or 2x, 2x. So 2 pi, so period is 2 pi. The phase shift here, you see the small b in lecture 15, it will be on the left here, shifting on the left. So the s, the phase shift minus 5 pi over 6. Let's put dp, so d is 2 pi divided by minus 5 pi over 6. So it will be 4 pi over 1 multiplied by the reciprocal here, 6 or minus 5 pi. Cancel the pi here. So minus 24 over 5 is the answer. Now question number 8, where the graph of the function f of x is equal minus square root of 3 cosine 2x minus sine 2x is above the x-axis on the interval minus 2 pi over 3 to 0. First, we have to graph this function. Graphing is not easy because we have cosines and sines, so we think of reduction. Reduction, we reduce this function into only sine function. Now, this is the given. Remember, you have to get the a. A is the coefficient of the sine, which is minus 1. B is the coefficient of the cosine, is minus square root of 3. Find k, square root of a squared plus b squared, which is 2. Now, let's find sine of phi, b over the k, which is minus this over 2. Cosine of the phi, a over k, so minus half. Both sine and cosine are negative, so phi will be in quadrant 3. And the reference here is pi over 3, because the cosine is half as the value. So in quadrant 3, phi will be pi plus pi over 3, which is 4 pi over 3. Now let's write the function, the given function, as 2 sine 2x. See, that's the argument here. See this x here in the formula, k sine x plus phi. Now this x is whatever argument in the question. So that will be 2 is the k, sine 2x is the argument here in the sine and the cosine, plus the phi, 4 pi over 3. So the correct argument here is 2x plus 4 pi over 3, and we need the period 2 pi over k. Now this k is the coefficient of the x from the formula. This is graphing sine function lecture 15. So 2 pi over k, this k the inside here, because this can be another number there. That's the amplitude. This is a, so the amplitude will be the absolute value of the a. So take the argument equal to 0. 2x plus 4 pi over 3 is equal to 0. So s will be minus 2 pi over 3. This is where the period starts. Now the argument equals 2 pi. E will be pi over 3. This is where the period ends. So we need now x-intercept. Because I need from minus 2 pi over 3 to 0, from this to 0 here, where is the graph above the x? See, this is above the x. The red one is the whole period. The blue is the whole graph of this function f. I need above the x. So I need this point here. So in the next slide, I have to find the x-intercept. You know, the x-intercept, put the argument equals n pi, where n is integer. So I take the correct argument here, 2x plus 4 pi over 3 is equal to n pi. So x will be minus 2 pi over 3 plus n pi over 2. That will give me all the x-intercept. See, I take n0, n1, n2, n minus 1, minus 2. If I take n0 here, see, I see this is the x-intercept. The one after that, I take n equals to 1. So put here 1, minus 2 pi over 3 plus pi over 2. So the LCD will be 6. So that will be minus 4 plus 3. So minus pi over 6. You see, that's x-intercept. Now, if you put n equals 2, it will be the other x-intercept, pi over 3. As I mentioned, the red one is one period. From here, minus 2 pi over 3 to pi over 3. The blue is the whole graph. Now, what is the green? Above the x. On the given interval, minus 2 pi over 3 to 0, see? So what is above the x? From minus 2 pi over 3 until minus pi over 6. So these two x-intercept here. That's above the x-axis. Now, this is an old exam question. Sine 40 degrees plus cosine 40 degrees is equal k sine alpha. Find the value of k squared alpha. Now start here with the left side. We can see by using reduction identity that capital A, the coefficient of the sine is 1, capital B, coefficient of the cosine is also 1, so k will be square root of 2. Now sine phi will be b over k, 1 over square root of 2. Cosine of the phi will be a over k, 1 over square root of 2. So phi will be 45 degrees in quadrant 1. So I can write here as the formula square root of 2, which is k, sine the x, which is 40, plus phi, 45. So that will be square root of 2 sine 85. Now let's compare. So the k here is square root of 2, and alpha is 85. So k squared, so multiply k squared here, 2 times 85, 170. Now this is also an old exam question. Let's simplify the expression. Sine 20 cosine 110 plus cosine 20 sine 110 divided by this, which is the correct answer, A, B, C, D, and E. It's nice to try it before you see the solution. If you like, you can pause the video and then we can share together the answer. I think, see, the numerator is ready for the addition of sine. The numerator here, sine 20 cosine 110 cosine 20 sine 110. So that's directly sine 20 plus 110. But this one here, we need some adjustments in the denominator. Cosine of the 40, I can make it sine 50 by cofunction. So cosine 40 will be sine 90 minus 40, sine 50. Cosine 10 will be sine 90 minus 10 will be sine 80. So this becomes here cosine 50, cosine 80 minus cosine 40, cosine 10. This becomes cosine 50, cosine 80 minus sine 50, sine 80. Then I can use the formula for cosine u plus v backwards. So let's continue on the next slide. So we see sine of 20 plus 110 will be sine of 130. And this is cosine 50 plus 80. It will be cosine 130, which is tan 130. Now, tan 130 is not in the answers. As you can see, maybe the answers here, there is no tan 130. So we have to change a little bit the answer. 130 is in quadrant 2. So we find the reference, 180 minus 130, and tangent function is negative in quadrant 2. So it will be tan 180 minus 130 minus tan 50 is the answer. C is the answer. Example 11 is a good question. We have cosecant of minus alpha is equal 5 over 4. Alpha is in quadrant 3. Let's find the value for this. Sine 3 pi over 2 plus alpha plus tan pi over 2 minus alpha. We can find each one separate and then we add. Start with the given. Cosecant of minus alpha is 5 over 4. So sine of minus alpha is 4 over 5, which is the reciprocal, as we know. Sine function is odd, so this becomes minus sine of alpha is equal 4 over 5. So sine of alpha finally is minus 4 over 5. This is y over r. So I can use x squared plus y squared is equal r squared to find the value of x. Now this is in quadrant 3. Why this is in quadrant 3? It is given here is in quadrant 3. So the x would be also minus. So cosine of alpha will be x over r, which is minus 3 over 5. So this is the required here. Sine of this plus tan of this. Now this is a cofunction here. It's easy to change all this tan pi over 2 minus alpha into cotan of alpha. Now use the formula for this, sine u plus v. So it will be sine of 3 pi over 2 cosine of alpha plus cosine 3 pi over 2 sine of alpha plus cotan of alpha for all this term. Sine 3 pi over 2 is minus 1. Cosine 3 pi over 2 is 0. So this becomes 0. And this is minus cosine alpha. We have the cosine alpha there. Minus 3 over 5, and the cotan of the alpha, 3 over 4. So we can put it here, 3 over 4. So now we have 3 over 5 plus 3 over 4, which is 27 over 20. The LCD is 20. Now let's, in example 12 here, let's find the range of this function, f of x pi over cosecant of x minus pi over secant of x plus pi times square root of 8. Now for the solution of example 12, we can start rewriting the function as pi sine of x, because this is the reciprocal of cosecant, minus pi cosine of x plus pi square root of 8. Now let's use reduction identity for only the first two terms. So capital A is the pi, capital B is the minus pi. So k will be this formula, square root of a squared plus b squared. So k will be pi square root of 2. Now in this example, no need to find the angle phi, but just in case you need it, sine of phi will be minus 1 over square root of 2, because it's b over k. Cosine of phi, 1 over square root of 2, which is a over k. Then phi will be 7 pi over 4 in quadrant 4. Now we don't need this in the range. So the function becomes This is now the a. This is the small a in the function sine. Pi square root of 2. This is the k. Sine x plus 7 pi over 4 plus 2 pi square root of 2. We get this from pi square root of 8, which is 2 pi square root of 2. So let's find the range on the next slide. So we have this function. We can remember the formula for the range of sine function, d minus absolute value of a, d plus absolute value of a. Small d is the coefficient of the sine there, so pi square root of 2. And small d is the shifting here up 2 pi square root of 2. Let's put all this in the formula for the range. So we get that one. Simplify the numbers. You will get the range pi square root of 2 to 3 pi square root of 2. Now here are some questions to practice on this reduction identity. Find the exact value of secant 285 degrees. So this is for lecture 21 and 22. Old exam question number 2, find the exact value of cotan 59 pi over 12. And then this is a nice idea here. We have sine of x plus y is minus 1 over 4. Sine x minus y 1 over 3. Find the value of cosine x times sine y. In this one, we have question number 4. Secant of a 3 over 2, a belongs to quadrant 4. Cosecant of a 3 over 2 and b belongs to quadrant 2. Let's find the cotan of a minus b. Simplify the expression here. We have tan 145 minus cotan 55 degrees, all divided by 1 plus tan 145 times cotan 55. Question number 6, find the exact value of sine 10 degrees times cosine 70 minus sine 80 times cosine 20. You can use here cofunction identities, I think, easier for you. Question number 7, we have f of x 5 sine 2x minus cosine 2x. If this function is written in the form m sine tx plus w, find the value of square root of 2 mtw divided by pi. Question number 8, we have if this function f of x 3 sine pi x plus 3 square root of 3 cosine of pi x is written in this form, a sine b x plus c in the bracket, and the period for this function is r, then find arc a times r times c. cb is there, but we don't use it in the answer. Now these are the final answers of all these 8 questions. Now for the complete solution, please, you can see the video on addition and subtraction formulas, also reduction identities, lectures 21 and 22 pre-calculus, all the exams questions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. Just to remind you that this is pre-calculus course, lecture number 22. I hope I can see you in another video with another topic. Thank you for listening.